clicker and you're gonna.
I'm not sure what everybody can see me. I thought I would start with talking about there's really two different kinds of applications. The one application is just looking for it. It's in the wrong box. And it's kind of Will's application. On this end, this is a USB to serial cable, and it's just, you know, USB on one side, you know, power, ground, transmit, receive on the other side. I think this might be the Nokia one, but you can buy them at SparkFun for about 15 bucks. On this side, I've got a serial camera, so it's a camera and it spits out serial images over TTL serial, and so I can plug it into my PC and get camera images.
But over USB?
Well, it's serial here.
Okay.
This is transmit, receive, standard serial.
Okay.
And then I happen to plug this into the PC, go serial. Right?
Okay. Okay.
Now, I happen to be running, if you want to get images at a reasonable rate, you want to run about 900 kilobits per second. And you still only get 5 or 10 images per second. Yeah.
So you're using. Go ahead.
Okay, before you leave that, is that what they call an SCCB interface?
A which?
SCCB?
No.
No, it is not. Okay.
No, this is well, actually I have 2 of these color cameras. I think this is the one from Lynxbright, and that's a whole different topic. It's a standard serial bus, very easy to interface. And
is that just, I don't want to waste too much time here, that'll help me. Is that the idea? I know that you can plug a serial mouse into a USB port. Is it because
no. This side here, Ron, is just, you probably have
standard serial. I mean, there's something in that cable. There's a little chip.
Yeah, I mean, you probably, this is this is like the SparkFun serial USB on one side, serial interface on the other side. You know, this is the chip that's actually
built in.
There's a
chip in the cable.
This is the FTDI chip.
There you go, FTDI.
The same chip built into Arduinos.
Okay. Okay.
And
this
chip is sitting inside the end of this cable. Okay. This is a slightly different camera, but same concept, and I just have it hooked up. In this case, I've hooked it up to a Zigbee. Zigbee is the little postage stamp module. It looks like this, right? Now, silly old Zigbee runs at 3.3 volts. Not Zigbee, XBee. I kind of use the two. XBee is probably the most popular variant. It's from a company used to be Maxstream, now called Digi, and they seem to be the de facto standard in the hobby robotics industry because it's so simple to use. Now, on this side, this is just a SparkFun carrier board. It's got another XBee chip on it, a USB interface on this side. Effectively, I now have a wireless replacement for that TTL serial cable. Good for, depending on which module we bought, well, they come in 6 different flavors of module. You notice this one's got a little antenna on it, a little bit better. This one, no visible antenna. In this corner, it's got, they call the chip antenna. And there's another one that instead of an antenna, it's got like an external jack that you can wire on one of these antennas, like the one that was sitting on the end of the Chumby thing. Okay, and what kind of range can you get? And so that's 3 flavors. Then they have low power and high power, so that gives you 6 flavors of XBees. And then they have something called Series 1 and Series 2, which are how much of the Zigbee protocol they support. So that gives you 12 flavors of the chips. The series, and what do they cost? Well, the $22 to $40, depending upon low power, high power. Okay.
And then you could double that. There's an international flavor, not quite double. It's 10 milliwatts instead of 50.
Yes.
So they limit you for international US.
Well, yeah, and that's the other thing on the yes, international is lower power than is allowed in the U.S. So they also say you can be internationally compliant by using the feature to say set the maximum power transmit level, which comes back to my sort of earlier comment about Wi-Fi taking 300 milliamps for high power Wi-Fi, biggest distance. Where I'm not sure. I think Wi-Fi dynamically adjusts the power level and measures how good the network is, but you can throttle on all of these Zigbee chips or XBee chips, and I think on Wi-Fi you can throttle what the maximum power you can transmit. So, Will, for your answer, I mean, you probably have something like this cable in your system today. Just
all I have is a notebook.
Well, no, on your robot. You plug into the US.
No. The robot itself has
No serial port on it?
But it's a Atmel, so it has capability of...
Here's the Atmel serial port. These right here.
Okay.
Transmit, receive, power and ground. Because it actually gets the power off the XBee here. So your simplest thing is cut this interface.
Well, okay, I've
Plug
got
this
pins,
in.
I've got pins on the microprocessor.
Okay, so you plug this in and use that one out of the box, and if you buy the right variant out of the box, it just works point-to-point serial, no configuration on your side. That's XBee's.
You got a birthday coming up soon?
Number what part is that you said is the right, the one that goes on the robot? Which one, what would I buy?
These,
Both identical.
these are both identical. The blue thing's XBee, and you need 2 of these carrier boards unless you want to make your own. And the carrier board is the Arduino, it's tapping the Arduino 5-volt power supply.
Well, I don't have
Well, but I'm just using the example. The XBees run at 3.
What does the XBee connector look like, or what is that?
I'm going to pass these around.
Okay.
Okay.
It's 2 millimeter. It's a weird connector.
Yes. It runs on 3.3 volt power supply. So on this board, in here, if you looked at it, you'll see there's a little 5 volt to 3.3 volt regulator, and there's some logic to make the I/O pins 3.3 volt tolerant.
I understand what you're saying. I need an XBee and
a pair of XBees.
And an adapter board.
Yes. XBee $20. Simple adapter board $10. The USB side adapter board, which has got this has got a mini USB connector on it, and it's got the FTDI chip, so it's $20. So in fact,
I need an adapter board and XBee.
I'm going to pass these ones around. I just want to make sure they all come back. So that's.
Well, it would be.
What?
Are they already?
I guess it's pretty humid. Huh?
They're what?
He's not worried about it.
He's worried about static.
Oh, here's Ron. Put
Here,
them
put
in
him in
here.
the tray. And
Yes.
Just be sure to shake them so they
Well,
have a nice
shit.
chunk.
I
know. Nothing
They're
ever
under
breaks.
warranty.
Yeah.
Okay.
Now, one other question.
It's not an option.
Yeah, I'm listening.
After I get this hardware, I'll talk to serial input on the microprocessor. What software do I need on the laptop?
Territory. No, I don't know. Terminal emulator.
Whatever you're currently using to talk to your serial, well then, TerraTerm or any one of the RS-232 terminal emulators.
There's probably a system-level discussion that ought to happen offline
Yeah,
here,
we'll talk
as
about
far as programming algorithms and interfaces and how you want to talk to it.
So here is another solution. In this case, the USB side, tiny little dongle, This is, we mentioned DF Robot. This is the DF Robot Series Bluetooth something or other. Bluetooth on one side. It looks to your PC like a serial link. On this side, it's got a Bluetooth module which also talks. So instead of using the XBees, you could use these two.
Cost?
$50.
He makes it up. You're not supposed to say, I don't know $50, just say $50. Okay.
I was going to say free. I got him to write an article, but I'll pass those ones around.
The range is what kills those. 10 meters at the most.
Well, it depends. Well, Bluetooth, there's 3 ranges for Bluetooth. One is a 1 meter range. You know, anybody got one of those Bluetooth headsets?
Yeah.
That's the very short range. Typically, it's a 1 meter range. Then the standard is like 10 meters, and there's a higher power, which is 100 meters. And let's see. I have another Bluetooth dongle, USB. This is like the 10 meter variant, and I don't know. This is the one that Lego uses in their competition. Recommends.
How do you know which is which? Like what color, what range level they are?
You look at the spec when you buy it, because they're I don't know. They're labeled Bluetooth 1 or Bluetooth 2. I forget what. And then this was I mean, you can't tell. This is the 100 meter one. And I think this was about $20, and this is was about $40. But that was 5 years ago when I bought these. I think nowadays you know, you can find them on Amazon for like as cheap as $2.
I'm sorry, Dick, I wasn't listening closely. Did you say there's some Bluetooth with a 100 meter range?
Yes.
Is it any good?
I'm sorry?
Is it any good?
Well,
my experience with Bluetooth has been like it's the one technology that never ever works.
No. Oh. Well, I got a lot of experience with Bluetooth, and often pairing it is often a pain, but it works. I don't know. You know, once it's connected, I've pumped 1 million messages, 2 million messages overnight with 0 errors, right? Because Bluetooth, let's see, I'm going to pass this one around. Some of you own like the Lego NXT, and if you look very carefully, if you pull it apart and you look, you'll see there's a little Bluetooth module on it. And actually, I was going through my parts bin last night and I came across this one. This is pretty fragile, so watch it. This was, you know, this was one of the original Lego NXTs, and they didn't have the Bluetooth module, but you notice it's like got about, when I pass it around, you'll see there's like room for, you know, it's just 6-pin connector, and it's just got the same kind of interface as all these other ones: transmit, receive, and power and ground. So if you're really good at writing firmware, you could hack the NXT and put Zigbee on, or XBees or something. Anyway, I thought I would pass this one around only because more because I thought it was interesting. The plastic case is done on a 3D printer, and you can kind of see it. It's kind of, you know, a lot of us built 3D printers, and this one's shows you what you can do with a really good 3D printer.
Is this a camera over Zigbee?
I'm sorry?
Yes.
Oh, well, you can. Yeah, I mean, Ron, here's the one with the module on it.
Okay.
Now, I think John had the question, what is a shield? This is a standard Arduino. This guy is what's called a shield, which just plugs in. Some shields are stackable, so you can stack multiple ones on top of it. I soldered the headers in, and I didn't get them just 90 degrees, so it's sometimes hard to plug it back in. But if you look on this shield, you can see there's a Zigbee. Actually, there's an interesting shield. It's got a Zigbee, a couple motor drivers, a speaker, and an LCD. But, sorry, I'm just plugging everything back in.
Was that
So-
an Arduino?
Yes, this is. I won't. I mean, this is an old Nokia $10 knockoff. Actually, I think this one was pulled out of a Nokia. It's still got the plastic part for holding it in, but from an old Nokia cell phone. But there's lots of different shields that you can buy for the Arduino that have the Zigbee. So you could take your Arduino, plug the shield in, and get XBee. Alternatively, and again I'm getting back at, so most of you guys, I mean, same Arduino, and it is literally, you know, and the Arduino has the USB interface, so for PC connectivity and for power. Instead of the PC interface, you could actually just plug one of these modules, you know, XBee modules that I'm talking about, and just plug it in, because transmit and power, these aren't quite the right pins because I didn't have the right cable with me when I was putting it together. But it's so instead of using the USB, you can just use the XBee. And that's such a popular configuration, they came out with something called the Arduino FIO, which is the funnel I/O, and that's this little module. If you look on the back, it's got an XBee on it, and all the power of an Arduino, but instead of programming it over USB, you program it over the XBee.
Does that mean you can just use your USB port for your data interface like you used to, like?
Instead of the USB parts, you just use the XBee, because on the PC side, the XBee looks like a USB to serial port. Okay.
What do you use on the PC side to connect XBee?
Well, that was one of the modules I passed around, but
So do they use like an extra I/O
it's
line?
like this one. I mean, it's the same one. It's got a USB mini, an FTDI chip underneath, and an XBee.
Oh.
So do they tap an I/O line to hit reset or something like that, so you can program it? Or
Yeah, it's a little bit awkward,
Hands
and
off.
some of them you have to hit the reset button, and they have just. That's because the guys who wrote the Arduino environment didn't know how properly. Well, on the PC you can. That's how Arduinos work. They wire the reset line to DTR. Which you can control individually on a PC, but if you're running Mac OS, you can't, so they got some other kludges, and that's a whole other discussion.
Okay.
Okay. And I'll do one other example, and then I'll start talking about a lot of, some of us have the VEX controller, right? The VEX Cortex, which is programmed by, one way to program it is USB program your system. The other way, and if you actually notice, you notice there's a USB 8-away cable, a little bit different than most of them, because the USB port here is on the go, it can switch either mode. So the other way to use this is to plug the Wi-Fi adapter in, which this is the VEX branded one, and we had a discussion earlier about using Wi-Fi adapters. Well, I saw them do it. I mean, you don't want to play with these unless you're running Linux and you're using somebody else's software. And I know the Innovation First guys, they bought the Jungo software stack that's going to support this stuff. You may have seen Jungo if anybody uses an AVR JTAG ICE. Some of us No? You look in the device manager, only you see Jungo devices because the JTAG ICE uses Jungo, some Israeli company that sells device drivers, horrendously expensive, tens of thousands of dollars. So in order to make this work with this, you buy a software stack for some tens of thousands of dollars. You take your best software engineer, you put him to work for a year and a half. You put two arms in here. One arm is the Cortex that you use, and the other one is dedicated for the driving the Wi-Fi, and you get it. So it's probably a little, and after you finish driving it, about the fastest you can get out of it is one Wi-Fi message per 10 milliseconds. So you need like the XBee, or you need an ARM9 or a Cortex A9 or something if you really want to use this level of thing. Now the other alternative, if you were doing XBee, which works just fine, and you had one of these, you take the XBee module, the same one we've just been passing around. You notice this guy's got two UART ports in it. Okay, I got XBee Wi-Fi. A little bit of software here, but not 2 man years of work. And in fact, the nice thing about the XBee support, because Paul talked about all the configuration you've got to do with Wi-Fi, and both the XBee and Bluetooth, all the different modules are really designed to make the configuration one time easy. And in fact, on all the XBee modules, all the configuration is stored in the XBee chip, so that it's kind of maybe done one time on the PC and it's there. It's not the intent that you're going to reconfigure the network very often. Once you've set it up, that's kind of the way it is. And then the actual code to send messages is, a whole XBee driver on an Arduino is less than 1K of code, as opposed to, the Wi-Fi driver on this guy, which is about 300K by the time they're finished.
On the Zigbee, say you want to, throttle back the data rate a little, is that difficult to do, or?
Oh, well, I don't know what you, so now we can talk about this chart. That was a good segue. Sorry, I'm just going to pick all this up.
Yeah,
let's not have you stand on it.
Well,
yeah, it would be uncool.
So data rates, Zigbee, there's 12 channels. I'm just going to talk about the North American variant. Each channel is 250 kilobits per second, raw bandwidth. So the best you're ever going to get is the 250 kilobits, as opposed to Wi-Fi sitting up here at megabits per second. Now, Bluetooth, well, it's there's Bluetooth 1.0 and Bluetooth 2.0, which is a little bit like USB 1.1 and USB 2.0 in terms of Bluetooth 2.0 went from, I think, 1.0 gave you up to 1 megabit per second. 2.0, I forget it, it's more, it's either 2 or 4 megabits per second. Now, you cannot throttle the bandwidth back that's actually used on the radio link. But you can set whatever baud rate you want to hook up to the different devices if you're hooking up like the XBees on the serial. And you can go whatever you want, down to 300 baud, up to
115.
Well, up to
doesn't work that way.
The XBee modules will work perfectly up to 200 kilobits per second.
Oh.
Except there's a little trick. If you read the forums, there's people that have troubles. Like the 115.2 kilobit per second, that's not a nice baud rate when you're taking a processor that's got an internal clock of 8 megahertz or 16 megahertz, and there's some kind of dividers to get you to that baud rate, and you don't actually get 115.2. You get, well, on the XBee side, you get 111 point something, and if you use the Arduino, you know, the algorithm says the best fit, and it turns out to be like 120. Now that's because the XBee and the Arduino both have slightly different clocks, and one has different divisors, and the difference between 111 and 120 is enough you get errors. And people say, "Oh shit, it doesn't work right." Well, the errors are nothing to do with the fact that the processor won't work. It's that the baud rates are mismatched. So that's why I say they work perfectly at 200 kilobit per second, because that's a nice divisor for both clocks.
Okay. What about 57.6? I've had good luck with that.
Yeah, well, I think, well, I just use 200.
Okay, I don't have that ability.
But I think 57, and I really didn't have any problems with 115, but I tried to move up to 230 and it didn't work, and that's when I found out it'll work great. And then above about 200, the XBee runs out of gas. Okay. Okay. So here we've got different bandwidths, and we talk about you know, different power levels, because the Wi-Fi, I think you do get better range, but at higher bandwidths it means it sucks more power, and that's a bit of a problem, because Paul mentioned that I said the XBee, literally July 28th, the guys that made it said we have almost a drop-in replacement that'll do Wi-Fi. Of course, it's not a $15, $20 module, it's $44. Okay. Only problem is the peak power draws is 280 milliamps. And I got a whole bunch of these SparkFun carriers with a power supply that's got 150 milliamp max drats, right? So they're going to have SparkFun, or I mean whoever, because I don't want to design these things. You need to boost up the 3.3 power output. But the XBee Wi-Fi modules, so they're using XBee as the brand name, and so they've got XBee Bluetooth. Now they've got XBee Wi-Fi. The user interface is almost identical, so it's going to be as easy to use, almost, as using an XBee, which is pretty easy to use. Oh, somebody else's chart. I got it's okay. That's with the internet. At least I'm acknowledging it. Oh, I don't know how to. Can you just click?
Yeah.
Okay. Within Bluetooth, and here's where I'm going to talk about the XBee Series 1 and Series 2. So, Zigbee was not really designed for doing, you know, data networking. It was designed for remote sensor monitoring. Typical application, think of a hotel room. They got a thermostat, a door monitor, door open, door closed, light switch on and off, and maybe a motion detector in the room. And some company comes in and says, Mr. Hotel Property Owner, I will save you bundles of money on your energy costs, because I'll turn the lights off, so I guess you got a light switch on and off as well. I'll turn the lights off and I'll turn the air conditioner off when nobody's in the room. And you're going to save 20% of your energy costs, and it's only going to cost you X $100 per room to retrofit your thing. First generation products, they ran wires, you know, I had to fish wires to hook all those up. The latest generation ones are typically Zigbee networks. Small little network, 5 nodes, and the door alarm is sending information back to the thermostat. The same with the light switch, same with the motion detector, and they can turn the AC off, turn all the lights off, and whoever sells it makes a bundle of money. And no, no fishing wires, no running wires under the carpet. Now, it doesn't matter whether it takes 10 seconds to get the data to the thermostat. I mean, there's no big real, what they want to make sure is the data actually gets there, not that it gets there fast. Now, if instead it's you with a joystick controlling your robot, you don't care if you want to send the stuff down to the robot 20 times a second, and you don't care if it drops, one of the packets doesn't get through. You want that 20 times a second or thereabouts bandwidth. And so the Zigbee 802.15.4 standard that Zigbee's based on, the first one was just a nice little low-level protocol. It only dealt with mesh networks. It only dealt with point-to-point star networks. I don't know what you call it. Think of it, what do you call this kind of network? But with where every point, well actually, the kind where every node is connected to every other node. And no forwarding between messages. That's kind of what Zigbee Series 1 does. There's no message forwarding, so you can...
No. Here. Okay.
It's no store and forward of messages.
Right. Okay.
If I can't see it, it doesn't reach, and that that would work well in the hotel room. But now, if you extend it and say, well, I've got the door key that I want to put in the. Is that the hook?
That's the hook. You're done.
Yeah. So. The other kind of application in that hotel scenario is you're down at the front desk and you're reprogramming the security code for the door swipe card, in which case now you've got a much bigger network, and you still want that data, and it may have to get forwarded many ways to get there. And the full Zigbee is a very reliable network, meaning guaranteed lossless as long as it can reach. It'll reroute around stuff, but it's not very fast, and if it has to reroute or if it loses connections, it may take 2 seconds to get there.
Full Zigbee is Series 2, is that?
Yes. So Series 2 is not what, unless you want that kind of network, it's not what hobbyists want. You want to use the Series 2.
The Series 2 modules are expensive also.
No, I think they're about the same.
30 to 40 bucks.
$1 or two more. The more expensive is the Pro versions that are the higher range.
2.5.
Yeah. So if you're choosing, go with the Series 1. And
yeah, I made that mistake. I bought a lot of Series 2, and I
Yeah,
got into it like, oh no.
yes.
So I can sell some Series 2, yeah.
I have some
can't-
too. I just assumed when I bought my first ones, I said, Series 2 must be better. I mean, it's just the same as it's not. Okay.
I'm sorry, can you explain that again? Why is the Series 2 not as good?
Well, because it gives you a reliable network. It gives you reliable, but you're trading off latency.
Good.
It may take you a message may take seconds.
For real-time stuff. I mean, when you're doing your joystick thing, that's when you want
Series 1 is point to point.
But if you're measuring temperatures in the room and
well, if you have to store and forward across multiple nodes, then you want Series 2. If instead you're only going point to point, then you want Series 1.
Right.
Now, all the types of networks, the type of I got this project I'm doing with robot swarms. Think of a robot soccer team. All the robots are sitting, here's the soccer field in front, smaller than this room, and the robots need to communicate with each other, and maybe they communicate with the PC that's still all in the room. And if it loses communication, something's wrong in my network. I want those updates to be done in near real time, not. Yeah.
So I take it if you get Series 2, it can't be configured for Series 1.
No. In fact, internally, Digi, when they went to it, the Series 2 have of course, there's an embedded processor, and it's a whole different processor family. There's no way to, the the Series 1 and Series 2 are firmware upgradable, but the Series 2 there is no support in the Series 2 hardware for just the simpler protocol.
Next slide, previous slide.
Oh, I'm taking next previous slide. I'm challenged. Oh, geez, I like this one. How did they come up with the name Zigbee? I guess it came. I have no idea if this is true or not, but it was. It sounds true. It sounded good. Okay, so here's a bunch of. So the other nice thing about Zigbee, again, thinking of the sensor network, I don't want to have to go back to that hotel room and change the battery in the door alarm. You know, like once a year is almost too much. So Zigbee's got all this wonderful stuff where the chips, they can go to sleep and then they can wake up every 10 seconds, squirt out a little bit of data, and then go back to sleep. And in the sleep mode, you know, they're drawing microamps. Let's get that one. Oh, okay.
So you're sort of using Zigbee and XBee interchangeably.
Yes,
Can you help me understand the difference between them?
XBee Series 2 is Zigbee standard compliant. XBee chips is the only one that has really easy to use interface for hobby standards. I mean, what the XBee company has done is, you know, they've taken $3 of technology, wrapped it in a bunch of firmware, sell it to you for $20, and it's easy to use. Now you can go out to you know, all the lots and lots. I believe an Atmel has a, you know, you can buy an Atmel AVR that has a built-in 2.4 gigahertz wireless stuff on it, but then you've got to write 40K of firmware that sits in the, where you take their stack and you got to modify it. You know, XBee is just out of the box easy to use.
So XBee is a brand and Zigbee is a standard?
Yes.
And both of them have XBee 1, XBee 2, and Zigbee 1, Zigbee 2?
Both, yes. Well, Series 1 sort of corresponds to 802.15 transport layer, and then Series 2 corresponds to the full 7-layer Zigbee stack. Very good. Do you want to ask one? Okay.
Quick question. So the
Sure.
so pretty much a firmware, softwareless solution, strictly hardware implemented. You can go RS-232 to USB to USB wirelessly. Is that correct?
That's that's what XBee will provide. So not our TTL level.
Oh, okay, not
ours.
Nice well, okay.
Yeah.
0 to 5.
So could you use it as a substitute for like a wireless printer driver?
I'm sorry.
Could you use the XBee USB device to drive your USB printer wirelessly, or is it not?
Well,
is it just?
Well, I don't think your USB. No. First, a couple of reasons. You wouldn't do that because I told you actually it's a good segue. That the Zigbee bandwidth, the physical transport bandwidth is 250 kilobits per second. But you start sticking the protocol overhead on it,
50%.
and with Series 1, you can maybe squeeze 50 kilobits per second out of it. With Series 2, you get 4 to 10 kilobits per second. Okay. Now, I don't think you want to drive your printer at 4 to 10 kilobits per second.
It'll take you about an hour to print a page or so.
Yeah. And okay. Now you can get better than that if what you're just doing. Now those numbers, just show what. And those are Digi's numbers, but they're based on short packet bursts. If instead you were sending long strings of data, like suppose you were just blapping 50,000 bytes out because you're downloading, you got no download, you got no error correction on your download, you just send it out, you will get much better than the 4.
But you will have
50.
errors in there,
Yeah.
so you've got to be tolerant
Well,
of
well,
those errors.
But
What-
the
what-
Zigbees in the XBee interface can also correct those errors for you if it's due to, because they have their own CRC checking
Well,
that's built into it. It's
But you'd have to send smaller packets to rely
Well,
on.
it already chops it up.
you have no choice. I mean, the XBee chip, well, you actually will packetize the maximum.
Okay.
What we'll send
Yeah,
is
it
100
chops it
characters
up.
at a
Okay,
time.
okay,
I
okay.
mean, the whole packet is, I forget, like 150 or somewhere between 150 and 200 kilobits, or 100, I'm sorry,
Bytes.
but 150 to 200 bytes,
Okay.
of which the maximum user payload is 100 bytes.
Okay.
And that's something that
That's
the
impressive
XBee
that they'll
chose
send that.
because, I mean, internally in the XBee is just like probably a little 8-bit processor with a handful of RAM, and you couldn't
Yeah.
get any better. Now, Zigbee XP uses CSMA, which is, and the normal way that XBee does is when the transmitter is ready to transmit, it briefly looks to say, is the wireless bandwidth in use? Meaning, is there any noise out there on the thing? No noise. Oh, I can transmit. It blasts its packet out, and then it sits and it waits, which always occurs because it's part of the transport layer protocol, to say the far end says, I just got your packet. If it doesn't get the answer back from that says I just got your packet, then it says, well, it failed, and it will back off, which is a random period of time. And so if two guys, if Paul and I are both transmitting, because we're both at the same time, of course you'll get a collision. He backs off, I back off, we both started with a random number, and how far we back off. He gets, hopefully we'll get through, because the next time, if we're the only two guys on it. And it'll do that by default, I think, 3 times. And each time, when it doesn't get through, if the random period for the first back off was, say, 2 milliseconds, so it'll be 0 to 2 milliseconds, say. On the second back off, it will be 4 milliseconds, and on the third back off, 8 milliseconds. So it waits longer and longer, and you work it through. And I think actually Wi-Fi works the same way on the physical transport. Yeah. Now, I think we talked about Series 1 versus Series 2 master slave. I may have used the words wrong, but one of the problems with Bluetooth, one of the Bluetooth implementations is it's very definitely a master-slave protocol. There's one guy who's the master, and everybody, and he can have up to 7 slaves connected to him. They all synchronize to his clock. So if they're not, whereas in Bluetooth, it doesn't matter. There's no need for different devices to actually synchronize. Now the reason in in Zigbee there's no need. The reason in Bluetooth they need to synchronize deals with the way they send a packet. The master, not only does he send the packet, the first few bytes of the packets, you know, if the packet is this long, there's a bunch of header up front, and part of the header has divided the rest of the packet into slots. And part of the header says, I'm using these slots, and Ron's one of my slaves, I want you to respond, and these are the slots you responded. And you can respond in these slots because he's somehow you pre-reserved your bandwidth, and I've forgotten the rest of the stuff. But the end result is, you better be synchronized to my clock, because as soon as I get the packet, when it's time for your slot, I start transmitting and immediately switch to receive mode, and I'm expecting to get your data back. And if you're not sending it back, it doesn't work. So the disadvantage of the master slave is in Zigbee, any node can start transmitting at any time. In Bluetooth, if I'm the master, I can send messages autonomously, but Ron, you can only send messages when I pull you and say, do you have a message? And you can only send messages to me if you're another one of the slaves. The message flow is always slave to master or master to slave. There's no slave to slave. And there is no tree structure or mesh network, because once you're a slave, you can't be the master for somebody else. So you can't have large networks at most. Oh.
Can you establish master?
No, it doesn't work. No, it doesn't work in Bluetooth. Because only one guy can be the clock source. I'm going to talk a little bit about the software.
Well, Dick, can you say something about, you sort of implied that there might be some latency guarantees with Bluetooth, since you were talking about guaranteeing a time slot. And this is a question I want for all of the technologies, to do some comparison at some point of the guaranteed latency and jitter for Wi-Fi, Zigbee, Bluetooth, and for Norton, for all of them at some point. So,
well, I think there is no guaranteed jitter. Okay. With Bluetooth, you how familiar are you with the USB standards?
Pretty well.
So in USB, you can have some devices can have guaranteed bandwidth slots, and then some of the bandwidth on USB is just reserved on a ad hoc for whoever wants it.
Right.
Bluetooth has the same kind of thing. So that when you have a Bluetooth stereo headset, when the initial connection is set up and negotiated, it says I'm a stereo headset and I need 128 kilobits per second of bandwidth, and you will get that. It will be pre-reserved, and you always get that slot. Versus the typical applications we're talking about is in the serial port emulation mode, which is
transfers.
Whatever's left over, you guys can share.
Yeah, I didn't know that Bluetooth had that. So.
The latest version of Bluetooth 2, I think, I forget the name of it, but it's apparently has lower latency than previous versions. Okay. And it's also lower power.
Okay.
But there's probably no jitter specs, right? Because a packet can always get dropped, and this protocol has to retry.
Right. Well, in that case, if it's isochronous, you don't retry it, just drop it.
Correct.
Yeah.
So.
Okay. I didn't know that.
On the types of devices that I'm talking about in the XBee sort of class of device, and all the different Bluetooth, who's familiar with the AT modem protocol command set?
All the old guys.
Yeah. Back when it was called the Hayes AT command set, then you're really old.
How many still have a Hayes?
Has it been preserved in like nitrogen or something?
It still works. That sounds good.
So for those that don't, I'm going to try and do the quick explanation. I'm sitting and Ron and I are talking. We're talking over a serial channel, and normally we're just sending data back and forth transparently. And there had to be some way that I can tell them, enter into a command mode, because I'm going to do things like change your baud rate, or turn your ringer off, or if it's a modem, or set the DTR. And the way it worked, it says, okay, let's go. I mean, the default mode is no transmission for 1 second, 3 consecutive plus signs, no transmission for 1 second, and now you're in command mode, and the data I'm sending to you is now commands rather than regular data. Yes, stand up, pee your pants, I don't know what command.
Okay, moving along.
Okay.
Sorry you waited too long, I exited command mode.
Yeah, absolutely, yeah. And one of the commands might have been, don't really wait 1 second. I mean, the 1 second was there, that guard time to something slower because it'll be better, or instead of using plus signs, we can use asterisks or change the bandwidth. But it's really, it was designed for point-to-point links, and you're not really swapping back and forth between command mode and data mode very often. You know, you'll go into command mode, you'll set everything up, and you'll set in the data mode, and that's all you use. And a lot of, I had it all in the chart. And they called it the AT commands, because once you got into command mode, every command began with ASCII AT, and then some kind of, the next letter told you which one of the commands, and then some parameters. And usually the far end would send back OK or error, with no good error message. So that point-to-point Bluetooth I had worked that way. A lot of the XBee actually works that way out of the box. Ron put up one of the pictures of Wi-Fi. I said Ron, but I meant Paul. He showed an Arduino Wi-Fi module. I think it might have been from Async Labs.
Yes, that's right.
Okay.
That's who it was.
Well, they do Wi-Fi and they use command modes. So that's great if all you're doing is setting up point-to-point. And they say, well, you can talk to multiple ports at a time. But if you want to switch from this port to a different port on Wi-Fi, you had to go in and out of command mode, which took 2 or 3 seconds. So you really can't talk to multiple ports at a time. So the XBee guys came up with something they called API mode, with application programming interface, where you switched out of command mode, and now everything is packetized. Skipping all this stuff. And I always send over XBee packets. You know, there's a preamble, a length field, then here's the type of packet I'm sending, then here's the data for the packet. Well, one of the types of packets I send is, this is actually data that you need to transmit somewhere, and so some of the other commands they're the commands like change my user interface baud rate, or change my network ID, or my PAN ID, or I don't know, there's about 50 of them. And I do all, and if you use not the API mode, but the AT mode, that's what I said at the beginning, where it was so easy to set up, because you just plug it in, you set the parameters up once, or even the guy has, you bought a pair of devices and they've just come, so they will configure themselves as a point-to-point connection, nothing for you to do, and works great. But then if you want to do, like I did, which talk to mesh networks, I had to use API mode. And that's what you can do with the new XBee Wi-Fi in the API mode. I mean, it's very simple. I mean, I just send, I think I've got an example, yes. The actual command to transmit a message from one node to another, you know, there's a sort of the 70, which is the delimiter that says this is the start of a command, here's the length, there's a checksum at the back, this is a transmit request, and I'm going to use, they've got a mode where it's either 16-bit addresses or 64-bit addresses. So this is within the data, you know, there's there's a frame identifier, which is usually a sequence number that you just bump, because when you get an acknowledgement back, it'll contain the frame number, and you can match that up against what you've sent. And then there's the 16-bit, you know, the different addresses and along with the data, and boom, it goes out. That's why, you know, 1K or less to write your Arduino driver, you know, 300 lines of code that you can copy from somebody, and versus tens of thousands of lines for Wi-Fi or USB.
Question about addresses. You talked about, like, XBees don't need configuration, they just like work together, but then I see some addresses there.
Well, okay.
As long as you're by yourself, not with somebody else who got theirs out of the box too.
All these devices are, first, in terms of addresses, XBee and Bluetooth, they all have a unique serial number programmed at the worldwide unique programmed at the factory. Think of it being like the Wi-Fi MAC address or Ethernet MAC address. Within that, within XBee, and that's a 64-byte address, you can also say, here is a unique identifier for a network ID that I want to use. So if we were all XBee chips, and if we were set up to use network identifier 28, we would only talk to other guys that were network identifier 28. We wouldn't talk to anybody else. And that way, a little bit of crude security, but would also avoid any message. You would not, if you were network identifier 58, you couldn't talk to me. And we would, I wouldn't see any of your messages. And there is a mode on both this series 1 where it'll just say, again, it works fine for us, you in your home, kind of like think of the Bluetooth stereo headset. I mean, you don't need to know the address or anything. You know, you just push a button to say, hook up, and as long as there's only one stereo headset or one Bluetooth headset around, you're the one you hooked up to. So Zigbee kind of has the same mode. I'm in configuration mode. Find me the one Zigbee that's out there, and that's.
So you have to like press reset on both of them to get them to find each other, like that sort of thing, like you do on.
Yeah.
So what do you do if there are multiple Zigbees in the same room?
Well, then it's more complicated setup. But once they set up, you can say lock that, store it in my internal flash, and we'll remember it.
But default out of the box with your Series 1, when you just buy them, you buy 2 of them, they'll talk to each other. But you got a problem if you walk into the room with someone else who just bought theirs, because they're going to default to talking to whatever it is, address 0, listening to address 1, or whatever it is. But at least that lets you get started. You didn't have to do any configuration whatsoever. But when you walk in here and somebody else has got theirs, then you're going to have to